Hello everybody, today I'm going to be showing you a compilation of some shaders I've made on my phone, which is kind of cool. I mean, hey, I hate sitting down in a chair, so I just, I would download programming apps for my phone so I can just program in my bed or whenever I'm in my spare time. And it's nice because, whenever you think of something, you can just whip out your phone and get started. So anyway, let's take a look at this one. So you may be wondering, what is this? Well, okay, you can tell maybe at this point that it's sort of like a bunch of waves emanating from this point here. But what's interesting too is that I can select sort of what time it is and what position it starts at, because this actually works by using, I don't know how to say, modes of vibration. There's like a bunch of modes of vibration that this thing could vibrate in. And yeah, actually, I'm terrible at explaining things. I mean, I didn't even know about it myself. I had to read some papers about it because I really wanted to do it. But it ends up just being this. You can select a time using the second pointer and see what it would look like from that position at that time. And it just calculates no matter what, where you are. Yeah, pretty cool. I don't know. I think that's cool. Okay, let's get to the next one already. Here we are. Let's go to this one. This one's pretty basic. It's just a Mandelbrot zoom, as usual. Yeah, Mandelbrot zoom is fun. So I'll just show you the whole thing. At least wait for it to zoom in all the way. I zoomed in to a specific place. I hand tuned the number, the complex number which it should zoom into. So it's unique, I picked it. As you can see, imagine how long it took me to figure out these. Yeah, not that long, maybe a couple minutes. Anyway, let's look at this one. Oh yeah, this was my wallpaper, but my Chinese spyware device, Huawei P20 Pro, doesn't let me set my wallpaper as this live wallpaper. It did. It let me do it like for one of the updates, and then it went away. So it's kind of sad. But actually, I had it so that you make it so that it's not animated, because that's terrible. Right. So what you do is you comment out one line and uncomment the other or whatever. And now this is an indication of what time it is right now. So as you can see, the moon, we're at high moon. Get high noon. Anyway, so it's midnight. And if you look at my time, I don't know if you can see, it says 12:08. So it uses the time. This one is pretty sweet. It's a combination of a sphere, a ray traced sphere. I had to figure out the right projection that I would use. I ended up using equal rectangular projection. I just got obviously a star image from online, and it also, what it does is it like checks if we're looking at the ocean of the Earth, then it replaces the just plain blue from the image with some like sparkly shine. And also, the sun is revolving around right now. Like if we were to look from the top, you can see the sun is going counterclockwise around the Earth. Or vice versa. I guess the Earth is going counterclockwise around the sun. Yeah, just making sure don't make any mistakes. Okay, and what I'm saying, and this is the code for it, doesn't matter, whatever. Camera swipe. Okay, you have to get this as soon as you... This is literally like that TikTok thing. Oh, shit. Camera front. Yeah, camera front doesn't work with this app, unfortunately. I don't know why. Maybe it's like the permissions just doesn't allow it. Permissions on my phone. Camera back. camera. Where is it here? Here it is. Camera front. It only works with the camera back, which means it's not as good as the TikTok filter, I guess. But it's just as good. See, or I don't know if it was an Instagram or TikTok filter. Look here. I won't lie. I frequent the social media. All right, here we go. Look at that. Wow, amazing. All right. So as you can see, that's some pretty simple code. Rock, paper, scissors. This is a cellular automata. And basically green eats blue, blue eats red, and red eats green. Pretty obvious. But actually, okay, this looks way more interesting if you touch it. Basically, if you touch it, it changes it into the consumer of that color. That's how the touch works. Nice. And then you get a bunch of spirals. Fun. Okay. This is like a pretty common, easy coding project, but it's better if you do it like a shader. And I modified it so that it would, how do I say, make more smooth shapes. Because if you do it in a really simple, basic way, then you get really simple, basic sort of. Actually, let me see if I can change the parameters right here so that it's more interesting. Threshold 2. Is that what I want? Because I think I made it so that you can just change a couple parameters. I'll change threshold and see what happens. I forgot what this threshold is for. Oh, actually, I know what the threshold's for. Okay, there's got to be one thing that I can do here. Modulo frame 3. I forgot what the parameter was. It was kind of like the smoothness parameter. Anyway, I'm sorry you had to see that. Had to see me fail to find it. Okay, this, I learned this in a mapping class, but basically, you can calculate whether a point is in a polygon using some really basic algorithm. And I thought that was pretty cool, so I ended up, going home and programming. Actually, I didn't even go home, obviously, because it's on my phone. I did it at school, back when there was no COVID. Oh yeah, you can do like a star, I think. Let's see. 1, 2, 3, 4, 5. Nice. That's a star. 1, 2, 3, 4, 5. That's not a star. 1, 2, 3, 4, 5. Ooh. Nice. Okay. So that one's pretty cool. Divergence. Okay, I shouldn't show this because it's literally nothing. I guess you could tell it was supposed to be something else because I called it divergence. This is another cellular automata, but it's obviously asymmetrical for one. And what else can be said about it? Basically, each cell turns on and off depending on the 2 pixels at the top left and top right of it. It just does the XOR of those things. So if they're both on, then it'll turn off. And if the top left and top right pixel, only one of them is on, then it will turn on. So it's like a super basic cellular automata, but it ends up making this, and it's pretty hard to see what's going on. I'm going to do this a little bit so you can see how you can do that. But, I mean, really, you might be able to tell. I actually originally made this just with the intention of making a Sierpinski triangle. But if we zoom in on it, basically, we can see what it was really going on. Maybe a little bit better. Yeah. And it's weird, like, it bounces off the walls, kind of. See? What? Pretty cool. Yeah, it bounces off the walls and they mix together with it mixes together with its reflected self. But yeah, you can see what's going on here. So that's nice. This is a wibbly wobbly surface. And what's interesting is that, okay, everything I made on this, if it's 3D, it's ray traced. So this is ray traced. But what's interesting is the way it finds the intersection, because this isn't made out of triangles and it's just a function. This works with any, like, I don't know what you call this, 2D function with two parameters and one output. But basically it works with any function, and it's able to find the intersection. And it does it by using bisection. There's bisection algorithm, I don't know, is a way of basically finding zeros or intersections or something. One way of computing basically anything in general. Okay, this is a Julia set. It's related to the Mandelbrot set. And there's a certain Julia set associated with every possible complex number. Some of them are very uninteresting, like this one. And some Julia sets are more interesting, like this one. So actually, this was originally meant to just be a complex function grapher, but I realized I could use the equations I wrote, which are just complex function equations. And I could use them to do a Julia set. So yeah. Change streaks. Oh yeah, this one's kind of cool. Yeah. What's interesting about this one is if we take a quick look, it does some hacky stuff. Because basically what I wanted to do was make it so that the pixel lights up depending on how much it's changed since the last frame. So it's really basic. As you can see, simple code here. But I couldn't make the pixel brighter, because then it's going to change from the last frame. And if it changed, anyway, so basically I had to stagger the output. We'll just take a look here. So half of these columns are for measuring the change. So right now, if I hold it still, all those dark columns means that nothing is changing about. And those dark columns light up when the pixels next to them light up. But the pixels next to them are just what's really in front of the camera. They have nothing to do with the change. But if you just zoom out gradually, we end up with this effect. Nice. Okay. Wow, cool. Anyway, speaking of using the pixels to store information, yeah, this program doesn't let you make your own buffers, spaces where you can store lots of information. So if you actually look at this membrane one, in order to store basically where the function started off, or where the point started off, in order to store the state of the wave, you can see on that bottom row, that's actually storing the information, all the basically the amplitudes of each mode needed to make what you see. And because this isn't enough space in this bottom row, it's messed up. So obviously it's not matching up with where my finger is. It's not correct, but it's not correct because there's not enough space to define a wave originating at my finger. But I think you have to use at least this much. And if you look very closely, you might see, I don't know if the video compression is going to ruin it, but there's a row of the information which holds everything about the wave. And you'll be impressed to know, if you've seen my video on voxel octree ray tracing, I originally did voxel octree ray tracing on a website. Well, not without the octree. Then I did this while I was tree planting. This is just voxel ray tracing without the octree. So this was original. I basically copied this code verbatim into onto my PC, and then I started modifying it until it got to where it was. Yeah. The difference is I had to write all the CPU code as well. This is just a shader, but it's better that way. Not without just being in a shader, because with the shader you end up recomputing many things for every single pixel, even though it's something that should only need to be computed once. But anyway, this is the same thing as that wavy wobby thing, except there's a picture of a mountain on it. Nice. And this one, I'm not even sure if this is correct. I think it is, though. This is the actual direction. I'm turning my phone right now. But basically, this is the actual direction of the magnetic field right now, according to my phone. According to my phone sensor. So yeah. I was gonna pretty it up and make it look like a full-fledged arrow. As you can tell, it doesn't even have that bottom circle surface. But anyway, this video has gone way too long. And I'm trying to keep my voice down because it's 12. Anyway, thanks for watching and have a good one.